Properties of chemical species are strongly dependent on their environments. For example, the properties of solids are vastly different than the properties of gases. One very important environment is the aqueous environment. This is where the chemical species is in a solution in which water is the solvent. One of the reasons we are interested in aqueous chemistry is because nearly all biochemistry occurs in water. Thus, it should not be a surprise that when astronomers go looking for life in outer space, they first look for water. In the aqueous environment, the dissolved chemical species are all surrounded or hydrated by the water molecules. In addition, water itself is dynamic in that there is always a certain percentage of water molecules that are disassociated and exist as the hydrated proton and the hydrated hydroxide ion. The type and amount of dissolved species affects the relative percentages of the protons and hydroxide ions that exist in the aqueous solution. So a very important distinction for chemical change that occurs in the aqueous environment is that water always participates in the chemical process. For example, aqueous acid-base chemistry always affects the dissociation of water. This is why, in aqueous solutions, water must always be considered as a key player in the chemical change.